Morning, 7th grade. Welcome to day 2 of week 5, April 21st. I'm going to show you briefly what you're responsible for today. So I'm going to click on your classwork tab. I'm going to go down to day 2. Going to click on the lesson. So you'll notice today that you again have the lesson as the PDF, and then you also have an optional link for support over here if needed. Okay, so I'm going to click on the lesson. We're going to continue identifying if a table is proportional or not, but they're going to be a little bit trickier today. So the warm-up gives you this table, again asking is it proportional or not. So at this point you should know the two things that makes a table proportional. Those two things would be if it has a constant and if it includes 0, 0. So looking at this table, I automatically see that there is 0, 0 included, so that's one check off. And then the only other thing I have to check for is if there's a constant. So I look for a pattern in my y's, which I do see, it's +4. I see a pattern in my x's, which is +1. So we would say yes, because there is a constant of 4, and it includes 0, 0. So yes, this table is proportional because of those two reasons. And that's what you guys worked on yesterday, okay? So we're going to get into some tables. Here's an example fully worked out where they're going to give you a table and there will be a constant visible that you'll be able to figure out, but there won't be 0, 0 included. So in that case, we have to do a little extra work and sometimes move backwards in our table by reversing our constant to see if 0, 0 would be there. Okay, so you basically are doing the same thing, just a little extra work to check for that 0, 0. And that's what's here. So I have our first example here. Okay, number of tickets versus cost. So the first thing you want to do is check for a constant. So we look for a pattern in our y's. Do we see a pattern happening? Yeah, the pattern happening is +3. Okay, we go to our x's. Do we see a pattern happening? Yes, the pattern is +2. So our constant is always going to be the change in y over the change in x. So our constant would be 3/2. And that is in simplest form. I'm going to just slide that over so I can write that for you. Change in y over change in x. This is in simplest form, so we can leave it like that. So check there's a constant, okay? Now, when we look at our table, 0, 0 is not there right now. So we need to figure out, well, where would it fall? Would I have to move forward in my table to get to 0, or would I have to go backwards? And for this table, we would have to go backwards. So we're just going to inverse our constant. So if our constant was +2 going downwards, if we want to reverse it and go backwards, we would -2. So 2 minus 2 is going to give us 0, which is one of the zeros we want. We have to check if the right side will also give us that other 0. So again, it was +3, +3, +3. We're going to do the inverse and -3. And 3 minus 3 gives me 0. So would 0 be included in this table? 0, 0, yes it would. So we can make that another checkpoint. And once these two have been satisfied, we say, yes, this is a proportional table. Okay, so those are the two things you want to look for. It's just going to be a little extra work because, like I said, sometimes you might need to move backwards in your table today to check. Okay, so I'm going to erase that so I have room for the next example to show you. I'll show you on your lesson exactly what I just modeled for you. Okay, showing the movement backwards and then stating your conclusion. Yes, it is proportional. Okay, there's another example here for you guys to practice, taking you through constant, 0, 0, etc. And then it goes into some tricky tables. So these tables are the ones where they don't look like they have a constant, but they actually do. So there's two options. First option is same thing we were doing. You're just going to have to simplify your constants to see if they are the same. And then, of course, check for 0, 0. The second option is to see if there's a constant ratio of y over x. And this strategy can only be used when checking for proportionality. You cannot use this strategy when looking for a constant in a linear table because it will not work. But if the table is proportional, then there will be this constant ratio of y over x. So I'm going to show you both so that you understand what we're talking about. So I'm going to copy this table down. So we have x of 5, 40, and 65, and then we have y of 1, 8, and 13. Okay, so the steps are the same as before. First thing we want to do is look for a constant. Now, when I look at these at first, they don't look like they do, because I know from 1 to 8, it's plus 7, and from 8 to 13, it's plus 5. That's not constant to me, but if we look at our x's, from 5 to 40, it's plus 35, and from 40 to 65, it's plus 15. No, 25, I'm sorry. Okay, so now since we have different numbers going on here, we have to see if when we put the change in y over the change in x, if they come out to be the same ratio when simplified. So let's check it out. So we have the first one was 7 was the change in y over 35. So we have 7 over 35, and that reduces to 1/5 because I could divide both of them by 7. Okay, now I'm going to check the second one. So again, change in y over the change in x. Let's see. Change in y was 5. Change in x was 25. 5 over 25 can reduce to 1/5 because I could divide them both by 5, and check that out. There is a constant. It's just they skipped numbers in the table to make it look like there wasn't. So there is a constant here. That's our first check. Okay, and then the second thing we want to do is check for 0, 0. So our constant, again, was the y changes by 1 and the x's change by 5. So now we're going to see if 0, 0 is included. So I'm going to use this constant. My y is changing by 1, my x is changing by 5. So instead of adding 1, I'm going to subtract 1. Why am I doing that? Because I know 1 minus 1 is 0, and that's what I'm looking for. And that's what my constant said, right? The y should change by 1. This table, they just skipped all those numbers in between. Could we change by 1? Yeah, they just they skipped them for some reason to try to throw you off, okay? So this would be minus 1, and then the change in x, we want to make minus 5. So I'm going to do 5 minus 5, and that, again, will give us that 0. So 0, 0 is included, and those are our two checks, right? Constant, 0, 0. This table is proportional. Okay? So these are those tricky ones that I just want to make sure you don't get stuck on because they are a little confusing. First of all, the constant is not as obvious as the other tables, but they do simplify. And then use that constant to see if you could go backwards to 0, 0.